There was a moment somewhere in your past when you almost died. Maybe you know exactly which one it is. A car that came from nowhere. A driver who ran a red light on a street you cross every day. A moment where the only reason you're here is because your foot lifted at a particular second. Or maybe it was quieter than that. A staircase. A wave. A moment in water where you went under and the panic arrived before you'd broken the surface. Or maybe you've half forgotten it, filed it away under close call and didn't look back. But here's what you don't know. Your body didn't file it away. In those seconds before you had a word for what was happening, your nervous system ran a program so precise and so fast that you had no part in it. You weren't the one who saved you. And it started before the moment you remember. Not with impact, not with sound. With a fraction of a second where your body already knew. Most people assume the story starts with adrenaline. Brain detects danger, adrenaline floods in, you react, fight or flight. Clean and simple. But that's not quite right. The real sequence starts earlier, and it starts before you're aware anything is wrong. In the 1990s, neuroscientist Joseph Ledoux at New York University spent years mapping the fear circuit. What he found changed how we understand the brain under threat. There are two routes your brain takes when it processes incoming information. The slow route runs through the cortex, the thinking brain. It evaluates what it's receiving, makes sense of it, and responds. That route takes 300 to 500 milliseconds. The fast route bypasses the cortex entirely. It sends raw sensory data straight to the amygdala, a small structure deep in your brain that does one thing extremely well. It detects threat. The amygdala fires faster than thought. It fires before you understand what you're looking at. In a near-death moment, your body reacts before your conscious mind has finished forming the thought, this is dangerous. You didn't decide to swerve, you swerved, and then you knew why. But that's only the beginning. Within milliseconds of the amygdala firing, it signals the hypothalamus, which triggers what's called the HPA axis. Hypothalamic, pituitary, adrenal. A chain reaction that starts in your brain and ends in your bloodstream. Your adrenal glands sitting just above your kidneys release a surge of epinephrine and norepinephrine. Your heart rate can double in under 3 seconds. Your pupils dilate. Your airways expand. Blood drains from your gut and reroutes to your muscles. Your liver dumps glucose into your bloodstream. Your pain threshold rises sharply. All of this while you're still inside the moment, before you've had time to be afraid. And then comes the part nobody talks about. Before the fight, before the flight. Before either of those, there's the freeze. For decades, fight or flight dominated the science. Two options, react or run. But in the 1970s, psychologist Gordon Gallup Jr. documented something present in almost every species ever studied a third state. He called it tonic immobility. Your nervous system has a fail-safe. When the threat is perceived as inescapable, when there's no time to fight and nowhere to run, the system doesn't escalate. It stops. Muscles lock, breathing shallows, movement ceases. From the outside, you look frozen. From the inside, something very different is happening. Survivors of accidents consistently describe the same thing, a strange stillness, almost calm. Time doing something it normally doesn't do. That's not a metaphor. When your brain is trying to survive, it doesn't have the luxury of processing information the normal way. It floods the system with everything it has. And one of the things it has is what researchers call hyperclarity, an intensification of perception so extreme that survivors describe seeing the world in unusual detail. The grain of a surface, the shape of a shadow, specific things their conscious mind was not trying to track. In the 1990s, behavioral researcher Alexis Artwohl studied law enforcement officers involved in critical incidents, shootings, crashes, violent confrontations. Roughly 2/3 reported that time slowed down dramatically. Some described seeing individual frames of movement. A half-second event stretched out into what felt like 4 or 5. Your brain doesn't actually slow time down. What it does is more interesting. It processes sensory information at a rate it cannot normally sustain. More data packed into each second, and because more is being processed per second, each second feels longer. This is your brain buying time, constructing the most complete picture it can of what's in front of you so it can find the best way out. Then you survive. And this is where it gets strange. Because the cascade doesn't end when the danger does. In the minutes that follow, you shake. That's real. After the sympathetic nervous system floods your body with stress hormones, the parasympathetic system rebounds hard. Your heart rate drops. Your muscles, primed for maximum output, begin releasing tension they no longer need. The shaking is the system discharging. Some people cry and don't know why. Some feel nauseous. Some feel an almost chemical wave of calm. All of it is the same process. Your body recalibrating after running at a level it was never built to sustain for long. Most things return to baseline. One thing doesn't, the memory. James McGaugh at the University of California, Irvine, spent decades studying how emotional intensity shapes memory formation. His conclusion was specific. Norepinephrine, The same hormone flooding your system during a near-death moment acts directly on the hippocampus. It enhances consolidation. It makes the memory stick harder, more completely, and in more detail than ordinary experiences ever could. Your brain has a tagging system. Ordinary moments get filed loosely. Moments when your life was at stake get burned in. The exact sound, the color of the light, the texture of whatever your hand grabbed onto. Things you were not trying to notice permanently stored. This is why people who nearly drowned 20 years ago can still feel the cold of the water. The brain made a decision in real time. That experience was the most important thing that had ever happened, and it kept it accordingly. Your nervous system ran all of this in the background, without asking. It knew before you did. It reacted before you could think. It froze, it flooded, it stretched time, it discharged, and then it made sure you would never forget. Every person you've ever met has a version of this stored somewhere. A moment when the system ran without them, when the machinery underneath the self took over completely and did its job. Most of the time, we live on top of that machinery without thinking about it. We make coffee, answer messages, and assume vaguely that we are in charge. But somewhere below all of that, the nervous system that kept you alive is still watching, still running its calculations, still holding on to the moments it decided mattered. The close call you half remember happened to your body. Your body remembers all of it.